has 6 sections total. So you're going to have a quiz on Thursday. Okay, it's going to be short, I know. Okay, it's not a super long quiz. The review's not really long either. It's just on your reflections, your translations, and then rotations that we're going to do today. Okay, so that's all your quizzes on. So I wouldn't worry too much about it. As long as you review the material, you'll be fine. So today we're going to go over rotations. Again, it's that third type of transformation we talked about on Friday. So a rotation is a transformation that moves every point of the pre-image through a specified angle and direction about a fixed point called the center of rotation. Okay, so we're rotating every single point of our figure around one central point, that's the center of rotation, and you're going a certain direction, either clockwise or counterclockwise. Okay, if the point being rotated is the center of rotation, then the image and pre-image are the same point. Okay, so if you're trying to rotate one point and it's the center of your rotation, it's going to rotate around itself. Okay, so it's just going to stay that same point. If the point being rotated is not the center of rotation, then the image and pre-image are the same distance from the center of rotation and the measure of the angle of rotation formed by the pre-image, center of rotation, and image point is x. So I'm going to show you kind of an example of how you're going to rotate. So I have this flag here. Okay, I'm going to label this top point point A. Okay, this point right here is going to be my center of rotation. Okay, so that point's your center of rotation. Now say I want to rotate all of those points 90 degrees clockwise. Okay, so that means all of my points now are rotating that 90 degrees. Okay, so you'd rotate each and every point clockwise till you get A prime, and that's at 90 degrees then. Okay, so that x value they're talking about here is your rotation angle. Okay, and we're rotating 90 degrees. So that's kind of what our rotation is going to look like. You have your center of rotation, you rotate a certain angle amount in a certain direction, all of those points from your pre-image. So in the coordinate plane, we do have certain rules to help us move these coordinates. Okay, so the following rules can be used to rotate a point either 90 degrees, 180 degrees, or 270 degrees counterclockwise. Okay, so these rules are for counterclockwise, not clockwise, counterclockwise. And they are about the origin. That means your center point is going to be the origin, 0, 0. Okay, so that center of rotation is at 0, 0 for all of our points here. So, to rotate 90 degrees counterclockwise, you need to multiply the y coordinate by -1. So you're going to take the opposite of what it is, and then interchange the x and y coordinates. Okay, so if I have, I'm going to add on this extra little chart to the back here. So my original coordinate is xy. Okay, that's my pre-image coordinate. To rotate 90 degrees, we would have the opposite of y, x. Okay, so we were multiplying our y coordinate by -1, so we take the opposite of y, and then interchange x and y, so flip-flop them. So that's why we get this -yx. For 180 degrees, all we have to do is multiply x and y by -1. So we just have to take the opposite of both of those. So we would change to opposite of x, opposite of y. We don't have to interchange anything. Okay, and then for 270, we multiply the x coordinate this time by -1. So take the opposite of our x and then interchange x and y. So again, we're flip-flopping those coordinates. So for this one, we would have y opposite of x as our new image coordinate. Okay, and again, these are all for counterclockwise. Okay, so it is counterclockwise. Questions so far before we do an example of a rotation? Okay. Then our first example here, we have parallelogram WXYZ with vertices WX, Y, and Z here. We want to graph that parallelogram and its image after a rotation of 270 degrees about the origin. Okay, so we want to first graph our pre-image, so graph each of these points. So I have point W at -2, +4. X is at 3, 6. Y is at 5, 2. And Z is at 0, 0. Okay, so here is my pre-image. So now what I want to do is find the image after a rotation of 270 degrees. Okay, so we're rotating 270 degrees about the origin. So we want to multiply the x coordinate by -1 and then interchange x and y. So that's the rule up in our chart for 270. Okay, so we're doing this rule here. Okay, and then we would have to interchange those. Oh no, we wouldn't. I lied. Ignore what I was writing. Okay, so we're doing this rule right here. So W is already done for us. So with this interchange piece, if it's easier to first multiply x by -1, we can do that first. So here, my original is -2, 4. So I would change my sign for my x value. So that would be 2, 4. Okay. And then to get W prime, I also have to interchange x and y. So I would have to switch those two values. And that's how they got W prime. Okay, so they just interchanged 2 and 4 to get that W prime value. Okay, so we'll do the same thing with x here. So first we want to take the opposite of our x value. So we would have -3, 6. And then to get x prime, we have to interchange those two values. So we would have 6, -3 as our x prime coordinate. Okay, same thing with y. Take the opposite of our x value first. So -5, 2. Then interchange the two. So switch them. We would have 2, -5. Okay, for z, I can't take the opposite of 0. It just stays 0. So I would have 0, 0. And if I switch those, I would still end up with 0, 0. Because the origin is the center of rotation, that point doesn't move. Okay, so it stays that same point. So now that I have all 4 of my points here, for my image, I can plot each of those points. So W prime is at 4, 2. X prime is at 6, negative 3. Y prime is at 2, negative 5. And Z prime stays at the origin. Okay, so again, this is a counterclockwise rotation about the origin. So it is going in this direction around this way. Okay, so that's 270 degrees around the origin to end up over here for each of your points. Okay, questions? All right, we're going to do some more examples here on the back. All right, so again, we have a pre-image and we want to graph its image after a rotation about the origin. So for number 1, we do have a trapezoid and we want a 90-degree rotation about the origin. So our rule for 90 degrees is opposite of y, x. Okay, so that's our rule. That's how we have to change each of our coordinates. So again, my first step here is to plot each of my original vertices. Okay, so point F is at 7, 7. G is at 9, 2. H is at 3, 2. And I is at 5, 7. Okay, and it should make that trapezoid. Okay, so now what I want to do is take my original vertices and change them using my rule here. So for F, I need the opposite of my y value, which is negative 7. Okay, so F prime would be negative 7, and then we want to take our x value, that is 7. Okay, for G prime, take the opposite of our y value is 2, so that would be negative 2. And then keep our x value the same, our x value was 9. For H prime, our y value is 2. We need to take the opposite of that, so that would be negative 2. And then keep our x value the same at 3. Then I prime, opposite of our y value is 7, so negative 7. And keep that x value the same at 5. Okay, so after I find each of those image coordinates, I can then plot those on my graph. Okay, so F prime is at negative 7, 7. Okay, G prime is at negative 2, 9. H prime is at negative 2, 3. I prime is at negative 7, 5. Okay, then I can connect each of my points. Shh, we're too loud. Okay, so here would be my image after that 90-degree counterclockwise rotation. Okay, questions on how I did number 1? All right, I want you guys to do number 4. Okay, so I want you to do number 4 here. Plot the points and then find the rule that was on the front of your note sheet to rotate that 270 degrees. Mm-hmm. You multiply that value by -1.
So that would be positive 1.
Yes. Mm-hmm. That's okay. I can tell you what the points are if you want me to.
Oh, did you say that your example was
Yeah. Yeah, I did. All right, so example 4 here. I have my pre-image plotted out on the graph. Okay, I want to rotate each of those points 270 degrees about the origin. So my rule there would be y opposite of x. Okay, so point P prime should be at 7, -4. Q prime should be at 6, -6. R prime should be at -2, -3. Okay, and S prime should be at -1, -1. Okay, so those are my 4 prime coordinates there. Now all I have to do is plot those. Okay, so point P prime is at 7, -4. Okay, Q prime is at 6, -6. R prime -2, -3. And S prime -1, -1. Okay, and then that would be that rotation 270 degrees counterclockwise about the origin. Okay, so now if I were ever to ask you to do this clockwise about the origin, right? Okay, I said I want you to rotate 90 degrees clockwise about the origin. What rule should you use? The 270 rule, okay? So 90 degrees clockwise is going to be the same spot as 270 counterclockwise. So it's just that opposite way. So if you think about it in this picture here, this is my original. This would be rotating 90 degrees clockwise. So if I were to go this way instead of backwards. Okay, so this way would be 90 clockwise instead of 270. So those are the same. 180 is always going to be 180. Doesn't matter if you're rotating clockwise or counterclockwise, since it is just that halfway around point. Does that make sense? If anything, that would be like an extra credit type problem, not anything else. So at the bottom, I do have a review of kind of what we've gone over so far. So in 5, 6, 7, and 8, we want to name the transformation that will map tree A onto the indicated tree. So tree A here, we want to map it out onto tree B. So what transformation could I use to do that? You have rotations, translations, and reflections.
Reflection.
I could use a reflection, right? Okay, I could reflect over this line right here. And then I would get that tree of B. Okay, what else could you do?
Translation.
You could also say it is a translation.
Excuse me, can I see Shayla, please?
Yes. All right, number 6 then, tree A to tree C. Okay, so tree A to tree C. What transformation could I use for that one?
Reflection.
A reflection. Good. Okay.
I think she wasn't in trouble. Just so you know.
What about tree A to tree D? We're not combining. A rotation. Okay, so I could rotate around this point here and rotate it either way here around to that tree of D. Okay, and then last one, A to E.
Double slide.
Not a double. You can just slide it once. Okay, so I could translate all of my points from A to E. So just slide them over. All right, last ones at the bottom here, 9, 10, and 11. So you're given a coordinate point and you want to reflect that in the given line. Okay, so for number 9, we have point M is at 4, 2, and we want to reflect it in the x-axis. Now, you don't even have to use this graph here. It's just there as a helper to you. Okay, so if you need to plot the point and then see where that reflection occurs. So we can plot this point M at 4, 2. Okay, and we want to reflect that in the x-axis. Okay, well, this is your x-axis right here. It's 2 away from that x-axis, so we'll go 2 further. And that would be your point M prime. Okay, that's what that graph is for. Now, however, we do have rules that we can use where we don't need the graph for this. So if you're reflecting in the x-axis, all you have to do is take the opposite of your y value. Okay, so all I would have to do is change my y value of 2 to -2, and that would be a reflection in the x-axis. And you'll see that when you find that coordinate point. You'd still have 4, but it'd then be -2. So you just have to change that y value. For number 10, again, you can plot the point and reflect it in the y-axis. However, with this one, all you would have to do is change your x value to the opposite this time. Okay, so n prime would be at -5, 1. And again, if you were to plot that, count to the y-axis, count away from again, plot your other point, and find that coordinate, you'd get -5, 1. For number 11, s is at 3, -2, and we want to reflect in the line y equals x. Do you remember the rule for that one? You what?
Wait,
I did not hear you.
both of them. I flipped both of them.
You flip the values around, so you interchange x and y when you are reflecting in the y equals x line. Okay, so this would be -2, 3. Okay, so you do have to remember those. So don't forget how to reflect in the y equals x line. Any questions on rotations?